Is it visible, sir, screen?
Yep,
Yeah.
it's visible.
Yeah, very good evening to everyone and good morning, sir, Professor Krishna Reddy, sir. So I would like to brief about Professor Krishna Reddy, sir. So, and then we will have his session. It's my privilege to introduce Professor Dr. Krishna R. Reddy of University of Illinois, Chicago. He is the Director of Sustainable Engineering Research Laboratory and Director Geotechnical and Geoenvironmental Engineering Laboratory at University of Illinois, Chicago. He has over 28 years of research, teaching and consulting experience within the broad fields of civil, geotechnical, materials and environmental engineering. More profusely in the field of geoenvironmental engineering and sustainable engineering. Dr. Reddy is the author of 4 major books and also author of 210 journal papers, 19 edited books and conference proceedings, 22 book chapters and 194 full conference papers. Dr. Reddy has given 185 invited presentations in the USA and 18 other countries. Dr. Reddy has received several awards for his excellence in research and teaching, including ASCE Wesley W. Horner Award, ASTM Argentollar Award, UIC Distinguished Research Award, University of Illinois Scholar Award, and Award for Excellence in Teaching. He is a Fellow of American Society of Civil Engineers and a Diplomat of Geotechnical Engineering and Board of Certified Environmental Engineer. He is also a registered professional civil engineer and EnvisionTM sustainability professional. So above and all, so he is a good human being and great teacher and inspirer. So I welcome you, sir. It's great privilege to introduce you. Now I request Professor Krishna Reddy to take up the session. Welcome, sir.
Okay, thank you so much, Ishwar Reddy, for that introduction. Can you allow me to share the screen?
Yeah, sir. I have made you host, sir.
Okay, okay, yeah, I got it. Thank you. Okay, can you see my screen?
Yes, sir. Yes, sir.
Okay. All right. So, first of all, good evening to everyone in India, and good morning to all those who have joined from US. First, safety message. Hope you are careful these days and staying safe. Hopefully, we will get back to normal days very soon. Hope you are watching this webinar from a safe position. Hope you are not driving, and hope you are not in a public, unsafe place. Hopefully, you are at home and comfortable and watching in a safe location. So I am happy that you are able to find time to join this webinar. I know these days there are so many webinars, all of them are interesting, but finding time to attend all these webinars is quite challenging. I am happy to be part of this program, faculty development program organized by Professor Ishwar Reddy. My topic title is Walk the Talk, Quantifying Sustainability in Engineering Projects. I purposely put Walk the Talk because, we hear a lot of talks about sustainability, but what can we really do, regarding sustainability? That's a big question. So I am kind of sick of, people saying how important sustainability is, but let's, undertake some actions to make that. I mean by that, I want to thank Ishwar Reddy for organizing this and inviting me to be one of the speakers. And I also want to congratulate the organizers, taking this sustainable engineering as a topic for this course. It's a very timely topic, and it is beneficial to all the attendees hopefully, you know, they will learn from this course and also use it some way, not just listen and forget. You know, hopefully, if you are a faculty member, you could use this information to teach, you know, in existing courses or teach a new course on sustainable engineering. Or, you know, if you are a practitioner, you could still, you know, use a lot of this information to justify or coming up with, you know, very unique sustainable engineering solutions. I also want to thank, I didn't get a chance to thank the college administration, faculty, and students. I visited the college last January when, you know, we had good happy days. And that memory, the trip was very memorable. And I just want to share a couple of pictures. You know, this is the college. Its infrastructure is very nice. I mean, like, it's a very beautiful campus with the greenery and nice architecture buildings. So I'm, you know, very glad to see the infrastructure of the college. And this is, you know, in front of their you know, main building with Reddy there. And I had an opportunity to meet faculty from civil engineering. It was very nice. I could see a lot of youngsters, and, you know, they're all like very, you know, excited about what they're doing in terms of teaching and stuff. And I also, you know, I had the opportunity to give a presentation to the faculty, all of the faculty in the college. That was very, you know, interesting. And I was thinking about what did I present, you know, and this is the photograph I have. And then I looked at the screen and said, like, oh, I talked about sustainable engineering challenges and application. It's like, wow, you know, there's probably I'm going to repeat the same thing. So I looked at you know, my presentation that I gave. So that made it easy to start my presentation. But you know, I made it different at that time. You know, just I gave a brief introduction to sustainable engineering and challenges and applications. So it was very nice to be introduced there. And I guess during that meeting, I you know, asked how I kind of indicated how important it is to teach sustainable engineering to the students. I'm very glad that college has taken up you know, revision in the curriculum, and they are actually offering a course on sustainable engineering. This is very much needed in you know, current curriculum. So I am from Chicago, so US. You know, Chicago is, and Chicago is a beautiful place for infrastructure and the environment. So this is kind of a civil engineer's dream to be in Chicago, witnessing all their creations. So in terms of my research, you know, I work on environmental remediation of soils, sediments, groundwater, and stormwater. So I work mostly on geo-environmental engineering. So dealing with, you know, cleanup of land, groundwater. So using different types of technologies, you know, again, trying to use, you know, bio-based sustainable technologies as much as possible. And developing these technologies, you know, through fundamental research in the lab. I also work on waste management and landfill engineering. I mean, you know, from sustainability point of view, you want to use as much of, you know, waste or byproducts that you get, you know, recycle and reuse. And if you cannot use it, you know, can you use some biological process to, you know, degrade or convert into value-added products? Or at the end, you know, no matter what you do, you're going to have some waste that needs to go to landfill. You know, instead of disposing in uncontrolled waste dumps, you know, can you engineer landfills and properly contain the waste in engineered containment systems? So I do a lot of research related to that. And then, you know, for the last several years, I've been working on this life cycle assessment and sustainable and resilient engineering. So which is the focus of this course. So I deal with, you know, quantifying the sustainability, you know, using different tools. And then once you have quantifying framework, that can be applied to, different applications. In my research, I apply for, evaluating the materials, evaluating the infrastructure, evaluating the waste management strategies, and then remediation systems. The framework can be applied to any kind of engineering system that you're dealing with. And then, my master's and PhD was in geotechnical engineering. So I do teach and also do some consulting in geotechnical engineering field. But a lot of my research is on this. There is nothing wrong about these things, but we don't consider these additional factors. One is the sustainability, okay? Another one is the life cycle thinking. Other one is the resiliency. So we don't consider these things at all in our conventional engineering teaching or practice. So it is high time to consider all these things. In fact, if you consider all these things, you could actually can come up with out of the box or innovative solutions or effective and economical solutions. So these are not only good in many ways, but also so the innovation comes out of using these things. Okay, so these are good. Like they say, okay, I want to consider all these things in addition to what I'm doing. So what should I do? I mean, first thing is about sustainability, right? So what is sustainability? I mean, a lot of people have seen this definition, that talks about sustainability. It's a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is the, the UN definition. It's very, powerful, very succinct and very powerful definition. So basically what we want to do is whatever the development that we want to, have, it should meet the present generation, but also we should not be affecting the future generations. Now the question is, are we doing something that is going to affect current generations and the future generations? So why should we care about sustainability? So one thing that, we should be worried about is the global climate change due to increased greenhouse gas emissions and the consequent extreme events. So it could be floods, droughts, wildfires, and so forth, So these things are happening, it's like global climate change is not a fiction. Now, it's a reality. So it's affecting, people, current generation as well as it's going to generate, it's going to create problems for the future generations. You see all this kind of data, the greenhouse gases, tremendous increase in greenhouse gases with time, and also, the global temperature increases. So these are, measured data, observations, you cannot refute it. And mainly because of, our practices that don't consider, greenhouse gas emissions. So, for example, we use a lot of, fossil fuel, coal, that's a very carbon intense energy source. So you're going to get a lot of emissions as a result of that, or natural gas. So you're going to get a lot of emissions as a result of that. So there are many sources of the greenhouse gases. Now it's, people are thinking about how could we, go after renewable energy sources and reduce the greenhouse gas emissions and try to mitigate this climate change problem. And climate change impacts are happening everywhere. I mean, they are not consistent. Some places it's going to be, maybe drought. Some places it's heavy snow. Some places it's a lot of flooding, hurricanes, tornadoes, ice melting, hunger, air pollution, and a lot of wildfires. These things are happening, and even in India, you see these recent, news on TV and newspapers. So a lot of unusual flooding, which never used to happen before, Maharashtra, Kerala, Tamil Nadu, Assam, Gujarat, many places, you can see that, you have extreme flooding situations, which was not common before. We are seeing these things happening more and more. And a lot of these things are attributed to the climate impacts. So it's time to think about, doing something for reducing the greenhouse gases, and also, going after some adaptable engineering strategies in the meantime. The other main problem is exploding population growth and consequent impacts. So overall, the population, this is again not a fiction, it's a real data. So you can see we have about more than 7.5 billion people right now, and it is expected to, reach, over 9 billion people in 2050. So this is not too far distance, think about it, and the growth has happened, recently, and it is increasing exponentially. So what happens with increasing population is, everybody has needs, so we are going to use a lot of natural resources, and these are finite in quantity. So we're going to, run out of these things. It's not like, again, not hypothetical. It could happen at the rate that we are consuming. Some of the natural resources could be exhausted. And then increased waste generation. Think about yourself. How much waste do you throw every day? So as the number of people increase, you're going to have more waste that is going to be generated. And then you saw in India, there are a lot of waste dump issues. And those kind of problems are going to even increase more as we go into the future. And increased pollution, right? You could have land pollution, water pollution, air pollution, as more people, do things, not manage the environment properly. And we could have a damage to ecosystem, right? And loss of biodiversity. Urban sprawl is a big issue because, a lot of people wants to live in the city, and the cities have grown up so much. So people are now, spreading outside the cities, right? Outside the cities, it used to be nice farmlands. Now, everything is built up with, residences and high-rise buildings. So that the precious, agricultural land is now, totally destroyed, and then you have urban sprawl that is happening. Economic disparities is happening. Some people are becoming richer and richer. Some people are remaining, poor, and also environmentally and in many other ways. When you have a lot of people, you could have social injustice issues also. So again, climate change is one issue that if we do something, we can perhaps slow it down and control it, deal with it by adaptation strategies. But with the population increase, we cannot do much about this one because it's a very sensitive issue. And no matter what scenarios you look at it, the population is going to increase. And as the population increases, believe me, like in just a few years down the road, things are going to be much different than what it is right now. So from sustainability point of view, we are enjoying certain things right now. But when this population is going to increase, everybody wants to have, more resources, more comforts, much better than what we have now. So then that, puts a lot of constraints on the environment, and it's going to get more problematic. Just urban sprawl. I mean, I don't have to say this one to you. You probably witness all the time. But I want to show you this video about Chicago. Chicago is in the 1850s. This is a small, tiny city. And look at it, how it expanded with time. You can see the year, and the geographically, how the construction started spreading, outside the city. So again, in 1895, see that city is expanding. People started to build outside, and that kept on continuing. And during certain years, due to economic boom and other things, so things have evolved. Right now, city of Chicago is very tiny, but you have all these lot of suburbs around it, So you have this urban sprawl is about, this expansion. And this is happening everywhere, right? I mean, even look at your town, how it used to be before and how it is now. And even now, people are going much outside the city and then building up. So this is a huge problem, and it creates a lot of issues. And a lot of things that we have done until now, we didn't really care about the environment. We looked after, okay, what we want, let's get it. You have magically the materials available, and use them and build them. So this is what happened. This shows the Human Development Index. That shows, like if you have more than 0.8, is a developed country, and if it's less than 0.8, is developing country. And so you can look at this one. So this quadrant that you see here, if you exceed above this line, that's beyond the planet's capability to recover. So ideally, you want to be in the sustainability quadrant. Ideally, you want to be developed country, but without compromising the planet Earth, right? But you look at all the countries. So the USA is the one top country. It's a developed country, but there are a lot of environmental, ecological damage that happened because during the constructions, during the development, this was not an issue. But now a lot of countries that are aspiring, a development, so they want to do it in a sustainable manner, not to cause ecological damage, but be developed nation. So this sustainability is a big concern. Actually, if you work in this field, there are some people they're highly committed, and they want to do something. Otherwise, the problems that we're going to face into the future are enormous. So United Nations is the organization that really promoting the sustainability globally. They developed these sustainable development goals, and they started these in 2016. So it's 4 years now, and the goal is to achieve all of these by 2030. So it's already 2020. So we have 10 more years to make tremendous progress. I mean, there is some progress made, but not as much as you want to see it. So in next 10 years, we should be doing a lot of things. But if you look at these goals, these are very broad goals, right? No poverty. I mean, very ambitious goals. You don't want to have any poverty. Zero hunger. So you can see all these things from civil engineers. They can play role in every directly or indirectly on every aspect of this SDGs. Some of them contribution is more than others, but these are very broad goals. And under each goal, there are targets. So for example, the Sustainable Development Goal 11, to make cities and human settlements inclusive, safe, resilient, and sustainable. So there are certain targets. You can look at these targets. I mean, these targets are also very. They are more informative in terms of what can be done to achieve those, goals. But again, these targets are very broad, very ambitious, and how do we get these things done? So sometimes you have really big plans, then you say, okay, oh my God, this is, what a mess, I'm overwhelmed, this is really a global scale problem, I don't want to have any poverty, in the planet globally. So how can I, do something about this? No hunger. What can I do for this kind of thing? So just you're sitting back, you're listening to this, and when I said all those things, okay, this is a problem. It's a global problem. What can I do? And these are very broad problems. Not designing a beam. If you're designing a beam, that's like, okay, easy thing, we can do it. So, eliminating poverty, globally is a huge challenge. It's a very broad challenge, right? So sometimes we look at these things and said, oh yeah, these are all very important, but, what can I do, to do something? I mean, whatever you can do it, we should do it, because everyone does something, and eventually it makes the difference. So I always say that, okay, to keep things under control on what you can do. So think about the scale of sustainability projects. Okay, So there are global level, right? The UN is doing a lot of global level initiatives, right, to achieve those goals. The national scale, like each country, set their targets. For example, India is very active in that one. So at the national level, you can create some like energy policies and other kind of things to reduce the fossil fuel consumption and promote a lot of renewable energy and effectively reducing the greenhouse gas emissions annually. So you can do a regional scale also, watershed. In a lot of water resources people deal with the watershed scale. So you can look at what can be done in that kind of situation. And then, business scale or institutional scale. For example, your college wants to have a zero waste initiative or, zero carbons, So you can also do certain things right on the campus or, as an industry, you can do all these things. And then sustainable technology scale is the things that we do day-to-day basis in our engineering field. So you don't have to do anything new, but whatever you're doing now, think about through this sustainability lens, can it be done differently? So you're using a lot of concrete and steel. Now they are well known that they are not, good materials from sustainability perspectives. Can we use the different materials instead of just the standard materials? So just we can think about as simple things as like that, material substitutions, kind of different way of looking at the designs, So we can do things which are in our control, not to worry too much about, doing in a broader scale. So everyone can contribute something towards the sustainability. Okay, I want to contribute something to the sustainability, but how can I do it, right? So if I look at the definition that, UN gave, that's very broad. It's not very helpful. So you need to have a functional definition. For civil engineers, we use ASCE definition. And this definition is slightly different than UN definition that you saw. This definition gives you a nice workable framework. What it is all about triple bottom line. When you talk about sustainability, so the main goals, main aim of the sustainability definition that is reflected in the general definition can be achieved by considering this triple bottom line. What is triple bottom line? Environmental, economic, and social aspects, okay? And we need to consider those aspects in whatever we're doing so that the quality of life can be maintained indefinitely. So like, this we should take care of the pollution problems, we should take care of, conservation of natural resources. So, social injustice. So all these things can be embedded in this triple bottom line concept. And if you can consider that one in your designs, then it's going to be, you're going to be, striving towards the sustainability. So this can be applied at different scales. You can be looking at, small project to the larger scale project. So in any scale, this triple bottom line framework can be applied and you can, achieve sustainability. Now I want to mention that, in sustainability is being practiced in industry. So I am from civil engineering field. So buildings, right? Buildings contribute quite a bit to the greenhouse gas emissions, waste generation, water consumption, and so forth. So these days in US, the buildings are designed as per the LEED. Okay, LEED certification is very important. So it's not required, but a lot of them use that because at the end, you're doing good for the environment. Also, you're going to save money in life cycle of the building. So we do the buildings based on, we design the buildings based on the LEED certification. LEED certification is basically a rating system. So you consider different aspects. Most of them are energy, water, materials, environmental quality, and all those things. So, what you look at those things and then how can you improve it? And, if you incorporated some features, then you get a score. Based on what is the overall score, if you get 80 and above, you can get maximum 110 points. If you get 80 to 100, you get a platinum certification. If you get a 60 to 79, it's a gold certification. So you know, the building, you say that gold rated, platinum rated, silver rated. These are, when you say that it's you know, gold rated, platinum rated, that means there are a lot of things engineers have considered to make that building more sustainable. But you know, one thing I want to say is in this rating system, it's all about environmental issues. You know, there are a lot of other issues, right? You know, of course, economic issues and social issues and resiliency issues. So you need to, you know, think about other aspects also. So the civil infrastructure is not just the buildings. You know, we civil engineers work in energy field, water field, waste field, transportation field, landscape and information technology field too. So you know, the civil infrastructure is much broader than just the, you know, buildings. So one problem that we had until recently was we didn't have any sustainability rating system for this type of infrastructure systems. So the lead is only for buildings. So we have the new rating system called Envision. Okay, so this Envision can be applied to any civil infrastructure that is other than buildings. So again, here, you know, it's truly sustainable because sustainability considerations are considered here. Quality of life, leadership, resource allocation, natural world, and climate and resiliency. These are different categories. Under each one, there are credits, just like a lead system. So you'll consider all these different considerations and give the scores. And depending upon the score, you get you know, different Envision certifications for the projects. So a lot of projects in the US are using this Envision system. And one problem with the Envision is it is applied to a larger scale. You know, if you have a small project, you know, this rating system may not be easily, you know, applicable. For example, at a citywide, you know, if you want to come up with a plan, then this makes a lot of sense to use it. But if I want to do something at a project level, let's say I want to design a retaining wall system. So which retaining wall is more sustainable? Okay. Or if I want to have a bridge, you know, crossing a river, okay, what kind of a bridge that I want to use it? How can I assess the sustainability? So this is we're talking about these things, not like even regional projects, but, you know, small in scope, and we can still apply sustainability. We want to apply it. But how do we assess these small scale projects is a big question. So, but we can go back to this functional definition of sustainability. So the triple bottom line. So we can look at environmental, social, economic, you know, these triple bottom line aspects, and then we can do something about it. So if you consider these three aspects, if we can develop indicators, and then if we can have metrics, and if we have tools to calculate these metrics, we should be able to assess how sustainable is our project. So the indicators, you know, we need to select indicators, you know, for environmental, economic, and social. What are the indicators? For example, for environmental, from sustainability point of view, greenhouse gases are very important, right? So the greenhouse gases, you know, will prevent, you know, climate related issues. So controlling the greenhouse gases is, you know, addressing these, you know, climate, you know, disasters that you see. So similarly, economic and social, and so they should be measurable, and we cannot just assign anything as an indicator. They need to follow the attributes of SMART. Like they need to be specific, measurable, accessible, relevant, timely. And if we have these kind of indicators, we can monitor them and see how we are performing, you know, or comparing different options in this one. So all the indicators should have some numerical values, and we should have tools to calculate those numerical values. For example, okay, for one of the environmental indicators is greenhouse gases, and we should be able to calculate, you know, what is the amount of greenhouse gas that is generated in our project. And we can use a simple carbon footprint analysis, or at a extreme high level, you can use the LCA, life cycle assessment, to calculate those things. So whatever the indicators that you come up with from environmental perspective or economic perspective or social perspective, so we need to really consider indicators and then values associated with that, and we calculate these things. So the whole you know, the concept about the sustainability is optimizing these indicators, positive impacts, we want to, improve that one, and then we reduce the negative impacts. So that's the whole goal of, this developed these indicators and the metrics and the tools to calculate. These are fairly established, So depending upon your application, there may be a tool that is available that gives you the indicators, that gives you the methodology to calculate them. And then LCA is a general methodology that can be applied to any situation. Like if you don't have any specific tool, then you can use this LCA to calculate the environmental sustainability. For a lot of them, when you say sustainability, they sometimes mean just the environmental sustainability. Okay, but true sustainability is beyond environmental sustainability. I mean, environmental sustainability is a major issue. People have been studying a lot. That's why we have, well-established indicators, well-established tools. But sustainability, by the definition, it's a much larger. So as I mentioned, this LCA, in courses now, everybody teaches this life cycle assessment. The good thing about this life cycle assessment is, in the very beginning of, this methodology, people were, doing it differently, and they were coming up with different outputs. So now that is not an issue, because we have an ISO standard 14040, and everybody is required to follow this one. So when you have a standardized procedure, it is a good thing. If you create your own methodology, then some people are going to be skeptical. Hey, I don't know how. So that's how the codes and standards, help. Because those are developed by people and after careful evaluation. So we have this methodology that has 4 steps in it: the goal and scope definition, life cycle inventory, life cycle impact assessment, and then interpretation of the results. And this is all like an iterative. You can see the arrows going back and forth. It's not a linear process. So this methodology is well established, extensively used. So I'm not worried too much about, quantifying the environmental sustainability. I'm more worried about these other aspects, the other 2 aspects of sustainability. Economic sustainability. In the economic sustainability, what are the indicators that we should be looking at, right? So this is the one thing that we always do: direct costs, right? If you have a project, we always look at it. Okay, how much is going to cost for raw materials? How much is going to be transportation, labor? So we can look at all these costs, but we don't pay that much attention to other than how much is going to cost. How much is the indirect cost? Okay, so some indirect costs could be like environmental costs, like a social cost of carbon, or all the environmental impacts, how they translate into monetary terms. All the environmental emissions will have some public health issues and other things. So you need to be looking at those things. And then, so those are costs, but there are a lot of benefits, right? Direct benefits. Let's say if you build a building, and then you opened a factory or opened an office, so you're going to create a lot of jobs, right? So that's the direct benefit of that project. So there are other indirect benefits. For example, if I'm using waste materials, so you would have spent money to dispose it off, and the environmental issues associated with that one. So you are preventing that one. So you can actually consider it as a benefit, and you can account that one in your monetary terms. But compared to environmental sustainability, for economic sustainability, the tools are not that developed. We have life cycle cost estimates, but also we have cost benefit analysis. We have a stepwise 2006, and we have a few other things. But more work needs to be done in terms of quantifying these different indicators of economic sustainability. When you go to the social sustainability, this is the most challenging one, and it is not addressed adequately. So when you talk about social sustainability, means if a project is going to be done in your neighborhood, okay, how an individual person in that neighborhood is going to be impacted by that? or the community in general is going to be impacted by that? What are the, socio-environmental benefits, environmental issues, socio-economic benefits or issues? So this is all about talking to the, talking about community issues, right? So in the traditional civil engineering or traditional engineering projects, we don't really worry about, the community, So we want to build a bridge in a neighborhood. We just go there and, okay, in the office, we think about this bridge should look like this. Oh, it looks beautiful, from designer's perspective. But we never get the feedback from the community, right? So if you have involved them, okay, these are the 3 architectural drawings. This is how if you choose this option, this is how it looks. This is how it looks. Second option. If you give them option, they might check like something. So if you brought them on board, and if they pick their option, then they think they are part of the project. And so these kind of things, the community involvement, is extremely important. But because this is, you need a social scientist to work with you when you're talking about social sustainability. So the metrics are scarce. We don't have a lot of metrics, and we don't have tools. But there are some tools that are being developed. For example, I developed a tool in 2013, social sustainability evaluation metrics. That kind of gives some framework. But likewise, there are other frameworks that are coming up, in the recent literature. And hopefully we will have more information on this one as we go further. Now, so this is how we look at it. You have economic indicators like this, and environmental indicators and social indicators. You have all these things. All right. So we need indicators, metrics, and tools to calculate these things. So now we have the numbers, right? So we want to be able to compare these numbers. Let's say I have 2 different options. So which option is better? And you will rarely see, one option having all the good numbers, So you can clearly say, oh, this option is better. But you will always see the conflicting results. One option will have, something's good. Other option will have something good. They have something bad, something bad. So you cannot really, make a good decision about it. That's a challenging part. I'm going to come to that one in a couple of minutes. So other thing that we are always neglecting is the life cycle thinking. So a lot of times, for example, in civil engineering, we don't think about, how the materials are made, but we assume that, okay, you want to build a bridge, right? So we know we need so much concrete, so much steel and all the things. So we order them. They come to the site and you build them, and then, there's some maintenance and that keeps on going. So a lot of our, civil engineers are involved in just the construction of it. But in fact, when you want to look at the sustainability thing, you need to look at the whole life cycle. Okay, what kind of materials you need, what kind of raw resources that you need. Going back into mining, right? So mining. What are the environmental issues with mining? Social issues with mining. Social issues, economic issues with mining. And then you bring all the materials to manufacturing plant, right? Cement or whatever, concrete. And then transportation. And then what do you do here? There are emissions associated with the making of the materials. And then you transport to the site, right? Transportation also a big contributor to greenhouse gases, And then on site, how you're constructing it, what are the things involved in it? What are the environmental emissions, so economic implications, social implications? Then maintenance, right? How you're going to do that one. And then at the end, you need to think about it, right? Even before the project, you need to think about, okay, my life's design life may be 100 years or 50 years, 30 years, whatever it is. After that, what am I going to do with that project? You don't want to leave that decision to the future generation. You want to keep that one in mind when you are starting up this project, right? So maybe you want to make sure that a lot of materials can be recycled and very little goes to the landfill. So you need to consider all these things. When you consider all these different life cycle stages, your solution could be different than just considering the on-site construction issues. So what we need to do is, the triple bottom line aspects, environmental, economic, and societal aspects, you need to consider at every life cycle stage, okay? You consider every life cycle stage, and then you add all of them together, So that becomes the overall environmental impacts, overall economic impacts, and overall social impacts. And then, you know, you can see how the sustainable the project is. And doing this kind of analysis every life cycle stage can also help you make decisions. What can you do different at that life cycle stage to make it more sustainable? So again, manufacturing. Let's say if manufacturing of cement, you know, causes a lot of problems. Hey, can I use something else? Okay, or what kind of materials cause, you know, what issues? If some things, you know, cause too much of environmental issues, then, you know, we can think about alternative materials like this. So overall, what we have is these life cycle stages that I mentioned: raw material acquisition, material manufacturing, transportation, construction, all these life cycle stages. And we need to apply this triple bottom line for each life cycle stage, and we get these indicators. Okay, these are, for example, red ones are environmental indicators, economic indicators, and social indicators. And these are indicators that have numbers. Okay, so engineers believe in numbers, right? So we have numbers, so we are able to define these indicators that have numerical values. And as I said, you know, this environmental is not a big problem. This economic ones, there needs to be a lot of work done to consider, you know, these indirect costs and benefits. And then social ones, you know, those are very hard to quantify, expressed by them by numerical terms, but things are evolving. You can do, you know, not so good job, but, you know, decent job now, and hopefully we can do better job as we go into the future. So we have all these things. If you think about it, I calculated all these metrics for each life cycle stage. I have this huge matrix of all these numbers. So what should I do? I told you that, you know, you're not going to get a clear-cut, you know, answer by just looking at these numbers, because these numbers are, you know, good. Some numbers are good for one scenario, and others are good, you know, another scenario. So then in your head you have a confusion. So what should I do? You know, which one is more sustainable? So that's when this, you know, kind of some methodology by which you can combine all these indicators, metrics, into some meaningful index. So that's called sustainability index. So how can we develop the sustainability index so that we can make a decision? So this requires multi-criteria decision analysis. You know, right? You have all these different criteria. So, you know, different numbers. So how do we come up with a sustainability index considering all these different aspects? So that's where, you know, we have been working on. This is not a established field. You know, everything is known, so you can follow it. But this is like evolving. We have been working on this kind of the methodology for a while, and you know, every time we work on it, we are making some progress. So this methodology includes certain different steps. Okay, so I'm going to go over very quickly these different steps so that you get an idea about how this can be done. So I'm going to go through these steps with some examples, so you can actually do this one yourself for a project that you may have. Okay. So this is called basically quantitative assessment of life cycle sustainability, or, you know, life cycle sustainability assessment. Okay. The step one is, okay, what is the project that you are dealing with, right? Define the technical design or design alternatives. Okay, I'm designing a bridge, right? So you have a technical design for the bridge. Or, you know, I have two types of bridge. One is the steel bridge, other one is the concrete bridge. Okay, so which one is sustainable? So you can calculate the sustainability index for one design, or you can calculate the sustainability index for multiple options so that you can pick which one is more sustainable, right? So that's kind of a standard design. I mean, that's where, you know, we do right now, you know, very good job. So you could have a project like, okay, you know, geothermal energy heating and cooling versus conventional heating and cooling. So you know that geothermal could be better, but you know how better it is. Okay, sometimes you know some things are better, but you need to quantify it. Deep foundation alternatives. So you have a multi-story building, you can have pile foundation, you can have a caissons or drill shafts. Which one is more sustainable? You can use pile foundations and, you know, or drill shafts. You know, they will do the job, but which one is more sustainable? So that's another thing. And if you are working in the environmental field, if you have a contaminated site, you may have multiple options for the remediation, So which one is more, better? So likewise, I'm just showing these as examples, but you can find multiple examples of these things. So what I'm going to do is, go through this framework, showing you by an example. So I try to use this framework in teaching my class, CME 514, Sustainable Engineering, and this is one of the projects that is done by the students. So the project is all about, geothermal heating and cooling system versus conventional heating and cooling system. Which one is sustainable? Let's quantify and demonstrate, the sustainability of both systems, so we can look at it. So hopefully, some of you are familiar with the geothermal energy systems or geothermal heating and cooling. Basically, you are utilizing the ground temperature. Below certain depth, the ground temperature does not vary, so we utilize that one. So we circulate the water, through a network of pipes, and then if you have a hot days, so we inject the heat into the ground, and then it gets cooled by the ground, and then the cooler water comes up, and then that gets utilized in the industry, in the building. Or the other way, if it is very cold, so you have a cold air, goes into the ground, and then that gets warmed up. That warm water comes up. So basically, you have a loop system, and then the heat pumps that need to be used, and you have a distribution system. So this is kind of geothermal heating and cooling systems. Now, a lot of people are using it. Even private houses are having these kind of systems. You can put these systems in your backyard, so you don't really have to, have any other resource for heating and cooling. So, as I mentioned, during the heating mode, so the cold, goes down, and then heat comes up. The reverse goes on in the other side. So, why we selected this project is at UIC in my university, these 3 buildings are put on geothermal system, okay? And so the question is, how sustainable this project is, okay? And we know that it saves 50% in energy consumption now, and because it's a geothermal system, you have 0 carbon emissions, and you always maintain whatever the constant temperature that you want, inside the building. So it's a no-brainer in terms of the sustainability projects. But the conventional system is, heating and cooling systems, fossil fuels, and so this, that these kind of systems are not very sustainable, but we want to quantify and let's see how it goes on. So these are the 3 buildings, and the geothermal systems involve, you could have a vertical loops or horizontal loops. In a big cities like Chicago, we cannot go horizontally, so basically we have vertical wells. So you have boreholes or vertical wells, and then that the piping goes through that boreholes, and then the heat exchange happens as a result of that one. So this is our campus. These are all the different lines of boreholes, and then all the tubing comes here, and then it goes into these buildings. So this is kind of more details about it. So this is each well, geothermal well, is about 500 feet deep. So it goes deep, and then the piping goes inside and comes out. So the piping is closed, and only the water gets circulated through the pipes. So this system that we have on our campus has 64 boreholes, each one going up to 550 feet deep. So you basically the HDPE pipes that goes through the borehole, and so that's the kind of a system that we have. So that's about step 1. So what is the technical design? What is the design alternatives that you are looking from quantification point of view? The second one is define hierarchical diagram or hierarchical sketch. So this requires in defining these requirements, criteria, and indicators. So basically, we want to apply triple bottom line framework So the requirements are, the triple bottom line, main thing, environmental, economic, and social. And within each of those triple bottom line dimension, we could have, multiple criteria. So, for example, environmental criteria, I may be dealing with all aspects of air pollution, maybe all aspects of water usage and impacts, land and ecosystem, so forth, right? And economic criteria, you're talking about direct costs, indirect costs. The social criteria could be, social, individual, community, economic, and environmental, so forth, right? So you have criteria. Under each criteria, for example, air pollution, so I should have indicators, right? Greenhouse gases, NOx, SOx, and so forth. So these are the kind of indicators. You have these indicators for each of these criteria. And each criteria feed into the requirements. So you need to come up with what should these be. Okay. So first thing is the requirement, right? So you have environmental, economic, and social that you're going to have it for all the projects, because we're going to look at the triple bottom line aspects. The criteria could vary depending upon the project that you're dealing with. In general, in the projects that I deal with, so I generally use these things, kind of same way in all the projects. But you could change it if you want. I mean, as I told you, we don't have a ISO standard for this one, so things are flexible right now. Hopefully, one day we have a standardized procedure to follow. So the criteria is, in the environmental, what are the different? I told you about air pollution, water usage, land ecosystem, direct and indirect costs in the economic and social aspects, what you have. And then you have indicators for each of these things, right? So these indicators. So this is very important right in the beginning. Okay, I want to consider the triple bottom line. What is the different criteria under each triple bottom line aspect? And what are the indicators for each of those criteria? Okay, so this defines your framework. You have to be extremely careful in terms of how you define these things. So once you define these things, okay, then you assign the weights for all parameters. So this is where a lot of debate and discussion comes in, okay, because all the parameters are not of equal importance. If you say all of them are equal, that's fine. You can go, proceed like that. But some things are important than other ones, right? So for assigning the weightages, okay, we need to do some rational way of doing it. How do we weigh the requirements? For example, requirements means how much I weigh for environmental, how much I weigh for economic, how much I weigh for social aspects. Should I make them equal? Okay, or should I give more importance to my social aspects compared to the environmental? And so, by default, the baseline could be everything is equally important. Okay, so that baseline analysis you can do it, but you can also analyze what would be the important thing, based on the stakeholders. Okay, whoever is, influenced by this project. It could be planners, it could be, government agencies, it could be public, it could be economists. So we want to know the weightages. So for that one, the rational approach is to follow hierarchical analysis procedure, AHP process, right? And AHP process is used in a lot of different fields. Now, we are using extensively in our sustainable engineering field. So basically, you weigh the factors, compared to that, to the other factor, how important it is. Okay, so you do this this matrix analysis, and then you send this one as a surveys to the stakeholders, and then once you get the responses, you can assign these scores, and then you can come up with the weighing factors like what I'm doing here. So here I'm showing by default, these criteria is equally weighed. The requirements is equally weighed, and criteria you can see, environmental, they're equally weighed, but the economic, I've got different weightages here. The 60% is direct cost, because direct cost is the actual cost. This indirect cost 20%, 20%, and then this social aspects, basically you get the data from surveys, public survey versus the project team survey. The project team has a better background on the project, so you give a higher weightage compared to the public. So these weightages can be given by the project team if they're comfortable, but best thing is to conduct a survey on the relative importance of these aspects, and use that information to come up with the weightages. So that's about assigning the weightages for the requirement, criteria, and indicators. Now the big challenge is calculate the value of each indicator. So we need to calculate those indicators. I told you environmental indicators, right? Like a greenhouse gases. So we need to calculate those things. Economic indicators, direct costs and indirect costs, we need to calculate those things. So as I told you, for environmental indicators, if you have a specialized tool to calculate those metrics, please use that one. There are tools for payments. There are tools for the materials. So if somebody developed a tool for a specific application, use that one. So you get the numbers, more reliable way that way. If not, you can always use LCA to get, these environmental indicators. Economic indicators, you have to calculate them. And the social indicators is, the way we do it is, we create a question project, and then we, try to send that questionnaire to the project team, and then, other project stakeholders, and we get all the scores, and then we evaluate the data. So here, the metrics is rating values, not like calculate specific numbers, but we look at the rating, specific the rating. Okay, this you can design the scale on the scale of 1 to 5. 5 is extremely important, 1 is least important or not important. So you can ask the people to assign those kind of ratings, and then you have those ratings as your metrics. So for environmental indicators, you can use the LCA, for example, for this project, geothermal and conventional systems. So these are all the environmental indicators that you get from LCA, and then normalizing that geothermal is this one. Geothermal sees very little effect as compared to the conventional system. So looking at all these things, global warming is these greenhouse gases. So this geothermal system emits only like 10% of what conventional heating system that develops. So same thing with all these other environmental impacts. So it's very clear that geothermal system is good system, but we are able to quantify this one, right? So and then actually instead of plotting, you can get actual numerical numbers. So what is the conventional heating and cooling system? What are the impacts? And the geothermal system, what are the impacts? So these are the indicators. They have units and they have numbers. That's what we are targeting in our framework. For the economic indicators, I told you direct costs. And we are good in calculating the direct costs. This is not a big challenge. The more challenge is calculating the indirect costs. There are certain ways we can do it, and things are evolving in this field. So raw materials costs, for conventional and the geothermal systems, you can calculate those costs. This is a cost estimate. A transportation cost for geothermal versus conventional transportation system. There's nothing for you to look at all the numbers, but I'm just showing you this one because we are good at creating the spreadsheets and calculating these numbers. A lot of our students do this, engineering, economics. We make them take a class, so the cost estimates. So we do this one for labor cost, and then we add these things. And this is the basic minimum we do for all our projects. The conventional is much cheaper than geothermal. Okay, so you say that, oh my God, geothermal is going to cost me double the money I have to pay for conventional. So this itself will kill the project of geothermal. If you just look at the cost-wise, geothermal is coming up. If you look at only the direct cost, it comes out with a bad option. But that it's a good option from sustainability point of view. But how the hell we can convince people that this is a good option, right? So we need to look at other things. So other things in this case is environmental, monetized environmental costs. So all these environmental impacts will have some costs. So for example, greenhouse gas emissions, per pound of how much environmental damage, how much is the public health issues with 1 pound of carbon. So going into details, I want you to look at the last table here. So if I look at this is the social cost of carbon. The greenhouse gases that are emitted by conventional system is going to be this much. For geothermal system is going to be this much. Okay. But then you look at the social sustainability aspects, right? Social sustainability aspects, as I told you, I use this social sustainability evaluation matrix, but you can use a lot of other things. So these are the social, individual, institutional, economic, and environmental aspects. So these are not really, high-tech, mathematical tools. Basically, it's a spreadsheets. So individually, as a person, living in that neighborhood, what kind of things that is going to be affected, and giving the rating for this one. So one is for conventional system. So you ask the same question: if you have a geothermal system, what would be the impacts? So, and this other one is the institutional or community. So you ask the communities what are the issues, and then you get their feedback through surveys, okay? And then you give the same questions on geothermal as this stuff. And then socio-economic issues, okay? For conventional heating and cooling, and you do this one same thing for geothermal system. So you're getting this feedback of people who are going to be affected by this: socio-economical, socio-environmental, and individual health and the community health, right? Community benefits and so forth. So we get all these scores, and then you can actually create a survey of these questions, and then distribute to all the stakeholders and try to get as many responses as possible. And then you can get summarize the results, something like this. For example, project team surveyed, and they looked at the social aspects, social institutional aspects, social economic aspects, social environmental. So these are kind of the scores that came up. And then looking at the survey of the stakeholders, all the stakeholders, external surveys, then you get these kind of factors that you can get. So individually, how people feel. So the negative 20 means it's really bad. 54 means it's really good. Individually. And you can look at it, all these are like, social, environmental is minus 91. It's really bad, conventional. But geothermal system is really highly positive. It's good. So it's not about cost. It's about social impacts and environmental impacts combined with the cost. So finally, we're going to have these things, we have environmental indicators, we have economic indicators, we have social indicators, right? So we have all these numbers. And once we have all these numbers, how do we, calculate a sustainability index? Now you look at these numbers, each one has a different unit, right? Some of them are in dollars, some of them in kilogram, whatever carbon dioxide equivalent, other social is some numbers. So when you have these kind of, indicators with mixed units, and a huge variation in the magnitude, we need to, normalize these things. So we use this value function concept. So the value function concept is we are trying to make these numbers from 0 to 1, okay? And we do that one based on this Miles approach, okay? So it's a multi-criteria analysis type approach. So in this one, you look at, the maximum value that it can have is 1, and minimum value can be 0. And you have to look at, the trend of that indicator, okay? So 1 means, you're always like looking at it's a good situation. Other one is a bad situation, right? So for greenhouse gases, so, as you decrease them, right, you have a better situation. You have 1. And as as the S minimum is max. So S minimum is max. So this you are basically related to the maximum and minimum. So you need to see how the increase in greenhouse gases is bad, right? And increase in social sustainability value, a particular individual value, that's good. So you need to have this behavior, how it is changing, what would be the shape of it. So based on that, you can use these equations to calculate the normalized values. And just want to show you some numbers here just as an example. Let's say, environmental, requirement and, criteria, and these are the indicators. These are the different values that we got, right? These are all the different values that we got from our analysis. And the tendency and the function that we want to use it. And then based on that, you can calculate all these numbers. At the end, you're going to get some numbers here. So all those numbers will vary between 0 and 1. So we do that one. I'm going to go a little bit faster. We do the same thing for economic dimensions. We look at the same thing for social dimensions. So basically, we got now all the values in terms of 0 to 1 with no units. Okay. Now we should be able to combine all of them, be able to calculate the sustainability index. For that one, so we have the indicator values. Remember, we got the weightages from our AHP process, and we have the value function, that's a normalized function. So we can combine all these weights and the value functions, and then we can come up with this, we can calculate this, right? So, and then we can calculate the same thing for criteria. So you have a weightages, and then for requirements, you have weightages, we can calculate these things. So this procedure, basically, you multiply the weightage factor to the value and sum them up. That is the indicators, and then at the criteria level you do that one, and at the requirement level you do that one, and then you sum them up, all of them, you get a sustainability index score, which is kind of nice. That's what we are looking for. So in this situation, if you look at it, if I just look at the environmental factors, this is my score. Economic factors, this is my score. Social factors, this is my score. When I combine all of them, right? So the total sustainability index is, environmental sustainability, economic sustainability, social sustainability, and then the overall sustainability index is this one. For conventional system is 0.13, geothermal system 0.87. So this shows that, the higher the number, one would be the ideal, right? Nothing can be ideal, there are always defects with anything that you can think of. So with this, approach, I can say, the sustainability index for geothermal is 0.87, conventional system is 0.13. Clearly, based on this quantification process, we are demonstrating that, even though, economic wise, it may not make sense in the beginning, right? But, when you look at the life cycle, right? So in the beginning, you are spending money, but during the life cycle, you're not paying for any electricity, and you're not using any emission. So in the life cycle, it comes up to be a good option. So this is how the quantification of the framework. When you have these numbers, you may disagree, and if you disagree with some numbers, ratings, and other things, we can always do some sensitivity analysis, parametric analysis. Okay, you want to vary this number, and even after varying this one, if the conclusion remains the same, there's no argument for that, right? So by doing these things you thought would be sustainable, they may not be sustainable. Actually, I got some projects where I thought the things are sustainable right from the beginning. At the end, they came out to be non-sustainable, and you can actually figure out why they are non-sustainable. Okay. So it's a kind of a very nice framework to apply. So I'm going to have some time for questions. So I'm going to wrap it up in a couple of minutes. So this framework can be applied to anything. So there may be some geotechnical engineers or structural engineers listening. So this is like a foundation. Okay, let's say you have a high-rise building and you need to have a foundation. This is the soil profile, and you can design the pile group. You can design the caisson or drill shaft. This you learn in class, right? Information design class, you learn this. So you design these two things, okay? I've got a pile group of 14 piles, pipe piles, and the caisson is basically drill shaft, 3 feet diameter, 4 feet high bell, 8 feet diameter at the base. So this is no-brainer. This is what we learn. Now, when you subject this one to the sustainability assessment, right? So environmental sustainability, economic sustainability, and social sustainability. So these are all the indicators for environmental, these are the economics, these are the social. When you combine all of them based on the framework that I mentioned, right? So you follow the step-by-step procedure, you get this answer, okay? The caissons or drill shafts are much more sustainable than pile foundations. Again, I want to caution everyone here that this is not a generalized conclusion. This conclusion is valid only for this project. Okay, so it's a project specific, conclusion. So don't generalize that, these caissons or drill shafts are going to be sustainable everywhere. So because, the specific location is involved, specific aspects of the projects are involved. So every sustainability assessment has to be project specific. Okay, so you cannot make a generalized conclusions out of it. But for this site in Chicago, for this building, caissons comes out to be the best option. So that's how you can say that if the owner has no preference, cost wise if they are the same, and from sustainability point of view, if you are going to do good by using the caissons, why not use that one, right? So we can educate these stakeholders. So we can apply this same framework for other things. So somebody who is in environmental, chemical, the fields. So remediation, cleanup of the sites is important. So this is the sediment in the lake was contaminated, and they wanted to dredge out the sediment. How do you clean up this contaminated lake, right? So these are the options they found out for cleaning up this lake. And then you apply the sustainability index, okay? And then you can look at this, this is monitor natural attenuation, dredging and disposal, conventional capping, modified capping. So you can learn more about these remediation technologies by referring to my papers. But you can see M&A is more sustainable. Second option would be modified capping. Third one is conventional capping and dredging and disposal. So all of them can do the job, but if I have to choose sustainable option, so this one is better. So if I don't have this quantitative framework, you and me will be arguing about it. You may argue that dredging and disposal is better, and I may be arguing that modified capping is better. So we will never end up anywhere. We keep on arguing. But when you have numbers, then numbers speak for themselves, right? So then, if you dispute my numbers, okay, we can work out all the details. Let's see what the final conclusion is. So the numbers can really help you a lot. And as I mentioned, you can do the sensitivity analysis. So ideally, I do with equal weightages as the baseline, but then you can, consider, okay, my social impacts are, or, my economic impacts are better, or, my environmental impacts are better. So you can actually apply different weightages and look at, what you get. So in general, if you have done the assessment correct, so the general conclusions won't change that much. So you may have magnitudes of the sustainability index varying, but your overall conclusions would be the same thing. So I want you to take this as a challenge, okay? Right now, we do the technical design based on the codes, regulations, and people started looking at the resiliency considerations. But I'm challenging you to, go one step further to the sustainability assessment. So look at the broader environmental impacts, broader economic impacts, broader social impacts. And you may have one particular design, but doing this assessment, you can find out where the negative impacts are coming. Maybe you can focus on changing those things to make it positive impacts. Or if you have different options, comparative options analysis, so you can apply the sustainability framework, as I mentioned, for those options and look at which one is more sustainable. If you can do this one, we are addressing the broader goal of sustainable development, sustainability. UN is doing, its part, globally, your countries are doing their part, and we need to do, as an individual, as a designer, as a engineer, we should be doing this one. So I really encourage everyone to, do this one. It's not a perfect thing, but by doing this one, things that you ignored will come into light, and you may be doing better job than what you have done before. So this life cycle sustainability assessment framework will give you the rational basis to select the most sustainable design. And LCA is a good tool to quantify environmental sustainability, but the challenge is with the life cycle economic and social sustainability aspects that are not fully developed, but do whatever you can. Don't say that, oh, tools are not developed, so we're not going to do anything about it. Try to develop a tool or try to do the best that you can. And I always mention that, when I showed this one in a presentation in Europe, somebody came after a presentation, told me that they require sustainable design in Europe, in some countries. I distinctly remember, a person from Austria, they said, like, they require, the sustainability part of their design. But in the US, we don't require, but things are evolving, and now more people are embracing this one, and then I would not be surprised, if this becomes a criteria. So my goal of this topic is not just talk. Okay, we can talk. I mean, I hear a lot of presentations on sustainability, but what can we do? Okay, how can we quantify and make good decisions on our engineering designs? So I want to end with a commercial for my book. So if you are interested in teaching sustainable engineering, you don't have to look any further than just getting hold of this book and then teach right from there. The best way to learn the subject is to teach, right? All those young faculty, all the faculty that were listening, if you say, oh, I don't know anything about this one, so don't get scared, So just get hold of this book and then, start preparing your lectures, go to the class, and teach as much as you can. So you can be honest with the students that, you are also learning. So you learn both ways, right? So Jeff Adams is one of the co-authors for this book. He's going to present tomorrow. So I hope you listen to him, this presentation. So I went too fast. There are a lot of publications. You can get those publications from my website. This is my email address. If you don't get a chance to ask me questions, if you are shy or because of the time limitations, feel free to send me email. I'm also on Twitter, Facebook, LinkedIn, and you can go onto these websites. You will find a lot of valuable resources. Even there is some information about teaching a sustainable engineering class. There are some videos and instructors resources. So I want to really thank Ishwar Reddy and organizers for giving me this opportunity. And if I have time, I will answer questions. But I know some of you have to go for dinner, so I don't want to make you wait. So you go ahead and you can ask me questions by email or otherwise. Keep in touch with me. Thanks a lot, Ishwar.
Yeah, sir. Thank you very much, sir. So I thank Professor Krishna Reddy for his valuable insight on sustainable engineering, starting from its importance and then framework and indicators and metrics and tools, then finally case studies. So how sustainability concepts has to be imbibed into engineering projects, and he has explained very clearly about geothermal engineering and conventional engineering application to a particular project. So with complete life cycle assessment and the costs involved in sustainability concepts, even though the cost is doubled, so we need to look at the sustainability of the project is concerned. So definitely, so this will improve in the society. So looking at sustainability aspects in each and every work that a government or an engineer or anybody, policy maker. So that is the intention. Awareness has to be created among the citizens, so that automatically people will try to imbibe sustainability in each and every project. So I thank Professor Krishna Reddy for his valuable lecture, and he is my inspirer. So I don't know about sustainable engineering before talking to him, and the environmental engineering. So I'm following him. So thank you very much, sir.
Yeah, thank you very much. Thanks, everyone.
Yeah, sir.
Have a great day. Good night. Good night, everyone.
For you, good day, sir. Bye, sir.
Bye.
Thank all the participants.